Balangeroite. Balangeroite is found in one of the most important chrysotile mines in Europe, the Balangero Serpentinite. Hence, it is usually mistaken as an asbestiform in an assemblage of other mineral phases like chrysotile, magnetite, and phenite alloys. However, Balangeroite does not lead to serious health problems caused by asbestos fibers. Introduction. Balangeroite is classified as an inosilicates with 4 periodic single chains, C4O12. It is a completely separate mineral from any true asbestos. It is economically important for providing building material, especially for thermal insulation purposes, fireproofing and so on. Recent publications by Tersa have drawn some conclusions that Balangeroite was not asbestos, had poor eco-persistence and biopersistence. This study also pointed out that it was the obvious chrysotile exposures there, not Balangeroite, that caused the incidence of mesotheliomas. Composition. The chemical formula for Balangeroite is Mg, Fe2, Fe3, Mn2COOH, and it has been calculated as shown in the diagram below by Compagnoni as follows. Table 1a. Chemical analysis of Balangeroite: CO2, TiO2, Al2O3, Fe2O3, Cr2O3, FeO, Mn, and GeOCOH2O turtle. Wet chemical, X-ray fluorescence, and electron microprobe analyses were used to deduce the composition of Balangeroite. The common intergrowth with chrysotile proved to be valuable in providing better chemical resolution, as portrayed in Table 1. The results varied due to submicroscopic intergrowths or zoning. From the wet chemical analysis, there was 9.5% average weight loss after calcination at 1000 degrees C due to the presence of water. This was calculated as the difference from 100% of microprobe results, with the assumption that large quantities of material usually contain some impurities and the possible oxidation of Fe2 under heating. A ratio of Fe2/Fe3 equal 2.12 was obtained, and on the basis of the known volume and density, the empirical formula for the unit cell was derived: Mg 25.7 to Fe2 7.69, Fe3 3.63, Mn2 1.65, Al 0.17, Co 0.7, C 0.1, Ti 0.1, total equals 38.93, C 15.38, O 53.66, OH 35.92. Structure. Balangeroite is based on an octahedral build that consists of channels that are filled by chains of silicate tetrahedra grouped in 3 and 4 rows running along the fiber axis. Balangeroite is isostructural to gadgite. In contrast to chrysotile, however, Balangeroite has more metal ions than silicon ions and might be in some cases seen as complex iron oxide containing some type of silicate structure in its framework. The surrounding fluid takes in a large number of the cations, which are octahedrally coordinated, which, unlike amphiboles, may be easily removed. As a consequence, the Mg and Fe are released, forcing the silicate structure to become loosely bound and therefore pass into solution. Further tests have been conducted on Balangeroite's ecopersistence, and it showed fairly low ecopersistence in neutral pH. Further studies were conducted by imitating weathering in an experiment to predict if weathered fibers retain the toxic potential present in freshly extracted fibers. The test proved that Balangeroite showed removal of Mg and C, which shows a continuous structural severance which extends far beyond the surface. Physical property. Balangeroite can develop as loose fibers or compact when in large volumes, which can be prismatic. Antigeroid flakes are included in relic prismatic Balangeroite, while transmission electron microscopy observation shows the fibrous Balangeroite is partially replaced by chrysotile. The fibers run a couple of centimeters in the geologic occurrences. The Piedmont Zone, remnant of the Piedmontese Ocean from the late Jurassic, is home to the majority of the serpentines of the Western Alps. The Balangero mine is located in the Lanzo ultramafic massif, which is in the inner part of the Piedmont Zone. The Lanzo ultramafic massif is believed to have been involved in the subduction processes that were affiliated with the closure of the Piedmontese Ocean in the late Jurassic. The earliest generation of metamorphic veins, and in particular type 1 vein that constitute relic prismatic Balangeroite, often includes antigeroid flakes, were formed during prograde high-pressure metamorphism. Fibrous Balangeroite is limited to the serpentine-infested rim of the northern Lanzo ultramafic massif, with its abundance in the inactive Balangero asbestos mine, where it was discovered. Balangeroite was named after the location in which it was discovered. Mine workers at the Balangero mine had first discovered it and named it based on its overall color and fibrous nature of other minerals present in the mine, xylitol or metixite. This new mineral, Balangeroite, was tested and found to be completely different from xylitol and metixite in composition as well as optical properties. Balangeroite was already discovered, and a somewhat pure specimen was in the Turin University Mineralogy Institute's museum since 1925, inventory number 14,873, labeled as fibrous serpentine asbestos and Vitter, Balangero.